class. Myself Prem. I'm studying in class 12. Now let us discuss 22nd of April Maths A class. So they have given the question. The points P comma Q denote the complex numbers Z1 comma Z2 in the Argand diagram. In the Argand diagram, O is the origin if Z1 into Z2 plus Z1 into Z2 is equals to 0. 2 is equals to 0. Then show that angle POQ is equals to 90 degrees. Okay. So they let solution. Let Z1 is equals to X1 plus Y1 and Z2 is equals to X2 plus IY2. Okay. This is Z1 bar. This is conjugate. Okay, normal Z1. Then are 2 points in the Argand plane. Okay. Let P of X1 comma Y1 comma Q of X2 comma Y2 are the points represented by complex numbers. Then O 0 comma 0 is the origin. Then slope of is O P Q. So the slope of OP is nothing but y2 minus y1 divided by x2 minus x1, which is nothing but y by y1 and x1. y1 x1 minus minus will get cancelled. Then slope of OQ is nothing but y2 by x2. Okay, from given equation, it is nothing but z1 to z2 plus z1 into z2 is equals to 0. Substitute these values. X1 plus iy1 into x2 minus iy2 plus x1 minus iy1 into x2 plus iy2 is equals to 0. Now we need to simplify. Upon simplification, we get 2x1 x2 plus 2y1 y2 is equals to 0. Taking 2 as common, then x1 x2 plus y1 y2 is equals to 0. Then taking 2 RHS, then it becomes 0. And at a time, y1 y2 is equals to minus of x1 x2. Okay. Next, substituting the values, which is by y1 x1 into y2 x2 is equals to minus 1. Okay, which is nothing but slope of OP into slope of OQ is nothing but minus 1. Then OP is perpendicular to OQ. Okay, then angle POQ is equals to 90 degrees. So hence we prove that we know that formula slope m1 into m2 is equals to minus 1 for perpendicular, which means 90 degrees. So these two are in perpendicular form, then angle automatically POQ is nothing but 90 degrees. Now let's go to second sums. Other question. the total number of complex numbers z satisfying re z square is equals to 0 and modulus of z is equals to root 3 is equal to, okay. So they have given that real number z square is equals to 0 and mod z is equals to root 3. Then z square is equals to, we know that z value is nothing but x plus iy whole square. Then z square is equals to x square minus y square. I square is nothing but minus 1 plus 2ixy. Then x square minus y square is equals to 0. Okay, is equals to 0. Then y square is equals to x square. Okay, from this equation mod of z is equals to mod of x plus iy is equals to root 3. Then we know that mod of x plus iy is nothing but root over x square plus y square. Root over x square plus y square is equals to root 3. Okay, then x square plus y square is equals to 3. Now put this equation here, x square minus 3 plus y square is equals to 0. Put y square is equals to x square, then x square minus 3 plus x square is equals to 0. Then 2x square minus 3 is equals to 0 and x square is equals to 3 by 2. Then x is equals to root over 3 by 2 plus or minus root 3 by 2. Therefore two complex numbers. Here since plus or minus are there, so two complex numbers. Now let's go to other sum. The expression tan of I into log a minus ib divided by a plus ib reduces to. So take given tan of I log of a minus ib divided by a plus ib. Okay, so we know the formula log of a minus ib divided by a plus ib is equals to minus 2 I tan inverse b by a. Tan inverse b by a. Okay, tan inverse b by a. Then substituting in that formula, then tan of I into minus 2i tan inverse b by a. Okay, just nothing but tan of I into I is nothing but I square, then I square is minus 1, minus 1 into minus 2 is nothing but plus 2 tan inverse b by a. Okay, so we know that formula 2 tan inverse x is equals to tan inverse 2x divided by 1 minus x square. 1 minus x square. Then substituting tan of tan inverse of 2 into b by a divided by 1 minus b square by a square. Tan will get cancelled. Then we get 2b by a into a square divided by b square. A square b square. Okay. Next a square minus b square. Sorry. A square minus b square. Hence LCM is there. Then square will get cancelled. And 2ab divided by a square minus b square is the final answer. Okay. Now let's go to other sum. Fourth, the number of complex numbers z satisfying mod z is equals to 1 and mod of z conjugate of z square plus z square is equals to 1 r. So they have given the values mod z is equals to 1, then x square plus y square is equals to 1, first equation. Then from this equation, conjugate of z plus z square plus, then this this will be square is equals to 1. So they have given this. Now uh, now what we need to do is putting the values of x is, we know that z is equals to x plus iy, x plus iy, then x plus is the conjugate of z is nothing but x minus iy whole square plus x plus iy is equals to 1 mod z square, then x square plus square y square minus 2ixy plus x square plus y square plus yi square plus 2ixy, okay, which is nothing but 1, and this x, oh wait, sorry, x square will be then x square minus y square, x square minus y square, that's it, plus x square minus y square is equals to 1. Then upon simplification we get x square minus y square mod is equals to 1, x square minus y square is equals to 1 by 2. This is second equation, okay. Now so now we can write as x square minus 1 plus x square is equals to 1 by 2, is equals to 1 by 2. Then 2x square is equals to 3 by 2, 3 by 2, okay, 3 by 2. Now sending to the that side, then x square is equals to 3 by 4, taking square to that side, then x is equals to root 3 by 2 plus or minus root 3 by 2, plus or minus root 3 by 2 from 1. 3 by 4 plus y square is equals to 1, 3 by 4 plus y square is equals to 1, then y square is equals to 1 by 4, y square is equals to 1 by 4, okay, which is nothing but y is equals to plus or minus 1 by 2. Therefore there are two complex numbers. This is 22nd of April class. I hope you all guys understood. Thank you.